Hi, welcome to the Olympiad Geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So the first thing I want to talk is that I still have some problems on the Excenter that I want to discuss about. But I think those problems are more difficult than the general IMO problems. That's the first reason I want to postpone the discussion. And the second reason is that some of them are related to other geometry centers, which I want to discuss about later. That I will have another chapter, mainly talk about the connections between these centers. So let's move on. In this video, I want to talk about the properties of the Excenter. Okay, let's just see it here. The property 1. The excenter of a triangle is the intersection point of the angle bisector of one interior angle and the angle bisectors of other two exterior angles. Each excenter has equal distance to three edges, right? Okay, let's just draw the figure first. So I have to do it like this way. Okay, we have A, B, C here. And let's just consider that ABC as our triangle, and we do the this one I make it looks more like a equilateral triangle, which is not good for our discussion. So let's draw another one here. This one is better. Okay. So A, B, C. Right. Now we are choosing the angle BAC as an interior angle, and we want to find the other two exterior angle. We do the angle bisector, right? Okay, so let's call this point as IA. Okay, and we know if we extend it, extend this one, and we find the angle bisector of this one. This would be IB, and this one would be IC. Okay, now we connect BIB, we connect CIC. Right, we know that the BIB is also the angle bisector of angle BABC, right? So the first thing that I want to talk about is that we know that the angle bisector of angle BAC, let's just simply call it angle A, right? The angle bisector of angle A and angle bisector of the exterior angle of angle B. So we know that the complementary angle of the angle B. So we know that these two angle bisector meet on a point, right? And that means at this point, due to it's on the angle bisector of angle A, so the distance to AB and the distance from this point to AC are equal. And also because this point is angle bisector is on the angle bisector of this angle. That means the distance from this point to the line AB and the distance of this point to line BC are equal. That means this is a point has equal distance on AB, BC, and AC, right? And that means it's also on the angle bisector of the complementary angle of the angle C, and also means it is a center of the X circle, right? So we can think about that. We can draw a circle here that is tangent to the line AB, BC, and AC, and IA would be the center of that circle. Okay, that's basically about the property 1. It's just introduce definition and the basic conception of the excenter. Okay, let's see the property 2. For given triangle, its 3 excenters. In this case, the given triangle is triangle ABC, and the 3 excenters are IA, IB, IC, right? And incenter would be this I. Form an isocenter group, right? If we remember that we discussed about the isocenter group in the isocenter chapter, it's basically saying that the 3 vertices of a triangle and its isocenter form an isocenter group, right? And basically we want to prove that IC, IA, IB, and I form an isocenter group. That means we want to prove that I is the isocenter of triangle IC, IA, IB, right? And it's obvious because BIB is the angle bisector of angle ABC, right? And we know that this angle plus angle B equals to 180 degree, and ICIA, this line, is the angle bisector of this angle. This line is the angle bisector of this angle. That means the angle IBBIA equals to 90 degree, right? Which means IB or BIB is perpendicular to ICIA. This line is perpendicular to this line. This is 90 degree, right? So this is 90 degree, this is 90 degree, this is 90 degree. That means I is the isocenter of triangle IAIBIC. Okay. And which means that I and IAIBIC form an isocenter group. Reversely, for a given triangle, in this case, that the given triangle is ICIAIB, right? The vertices and the isocenter, which means the vertices is IA, IB, IC, these 3 points, and the isocenter is I, are the excenter and incenter for its parallel triangle. The parallel triangle is triangle ABC here, right? That's obvious. Okay, for the property 3, the angle BIAC equals to 90 degree minus half of angle A, and angle BIBC equals to angle BICC equals to half of angle A. So notice that this is 90 degree, this is 90 degree. We know that IC, A, I, B, these 4 points are cyclic, right? These 4 points are cyclic, which means angle BICI equals to angle BAI equals to half of angle A equals to angle CAI equals to, because this is 90 degrees, this is 90 degrees, so we know that IBAIC are cyclic, right? We know that IBAIC are cyclic as well. So this angle equals to this angle equals to this one, and this one also equals to this one, equals to angle CIBI. Right, so these four angles are equal to each other, equals to half of angle A, which is this part, right? The angle BIBC, angle BIBC, that is angle CIBI, right? So this equals to angle BIBC, and this one, the angle BICI equals to angle BICC, right? Or C, yeah, so we just proved the second half, right? For the angle BIAC, for this angle, let's just look at it here. This one, the angle, because this is 90 degrees, this is 90 degrees, so we know that BICIA are cyclic. Actually, all of this we already discussed about, all of this we already discussed about in the Excenter chapter, right? So we should be familiar with these cyclic quadrilaterals. These 4 points are cyclic, which means this angle equals to this angle, right? So the angle BIAI equals to angle BCI equals to half of angle C, and angle CIAI, this one, equals to angle CBI, right, equals to half of angle B, which means angle BIAC equals to half of angle B plus half of angle C. We already know that angle A plus angle B plus angle C equals to 180 degrees, right? That means half of them, the summation of half of them is 90 degrees, which means half of angle B plus half of angle C equals to 90 degrees minus half of angle A, right? That's property 3. Now we look at the property 4. Okay, property 4 is asking us to calculate the radius of the X circle. The RA equals to twice of the triangle area. This triangle is the triangle ABC divided by minus A plus B plus C. ABC represent for the length of length of BC, AC, and AB, right? Equals to 4 times R. R is the radius of the circumcircle of triangle ABC. 4 times R times sine half of angle A, cosine half of angle B, cosine half of angle C equals to R. R is the radius of the incenter of triangle ABC. R times cotangent half of angle B times cotangent half of angle C. So before we really do the calculation or do the proof for this one, let's just look at the figure itself. Let's do some derivation first, right? We already know the relation of these points of the cyclic quadrilaterals, so we're already familiar with that. Now let's think about, we want to calculate about the RA, which is the radius of the X circle, which means that it's basically the distance from the excenter IA to the line AB, line BC, and the line AC, right? So let's just find the projection here. Let's call, I didn't draw the figure very well, right? So it may mislead, but please bear with me. Here, let's call this point as D, this point as E, okay? So we already know that BIA is angle bisector, of angle CBE, right? Which means this angle EBIA equals to angle CBIA, right? So, and we already know that this is 90 degrees, this side is 90 degrees, which means these two triangles, the triangle EBEIA and the triangle BDIA, also has the equal side of BIA, which means the triangle EBIA is congruent to triangle DBIA, right? Which means BE equals to BD. Similarly, if we draw the projection we find here, let's call it F, right? We know that angle BCIA, this one, equals to angle FCIA, right? Because CIA is the angle bisector of angle BCF. And also, this is 90 degrees, this is 90 degrees. IAC equals to IAC. That means the triangle DCIA is congruent to triangle FCIA, which means we know that here we still have another one, that is EIA equals to DIA, right? And here we know that DC equals to FC and DIA equals to FIA, right? And if you remember that we talk about the 9-point circle, we talked about the 9-point circle before, right? I'm not sure, maybe half a year ago, we discussed about the 9-point circle. And we know that the radius of the 9-point circle is half of the circumcircle for a certain triangle, right? So if we look at the triangle IAIBIC, because ABC, the triangle ABC is the pedal triangle of the triangle IAIBIC. So we know that the 9-point circle is a circumcircle of the triangle ABC, right? And we already said that the radius of triangle ABC equals to R, right? And we know that triangle ABC, the circumcircle of radius of the circumcircle, right? Radius of the circumcircle of triangle ABC is R, and we know that the circumcircle of triangle ABC is actually the 9-point circle of the triangle IAIBIC, which means that the radius of circumcircle of triangle IAIBIC equals to 2R, right? All of this can be found the proof in the discussion of the 9-point circle. Please just review the 9-point circle videos, right? So we don't need to discuss all of these repeatedly. Okay, now we have some basic information here. Now we can do the calculation. The first thing is that we want to find the distance of the EIA, right? And if we look at the calculation for the area of AEIAF, right? So we can write it as the area of AEIAF equals to the summation of the triangle area AEIA and the triangle area of triangle AFIA, right? It equals to half of AE times EIA plus half of AF times FIA, right? And both EIA and FIA are RA, right? So A equals 2 half of AE plus AF times RA. That's the area of this one. And if we look at the area of the EBCFIA, right? So BEIAFC, it equals to the area of BEIA plus area of triangle area BCIA plus triangle area CFIA, right? So it equals to as triangle BEIA plus as triangle BCIA plus triangle CFIA, right? And we already know that triangle BEIA is congruent to triangle BDIA, and triangle CDIA is congruent to triangle CFIA. That means the area of this one plus this one equals to the area of this one, right? So it equals to twice of the area of triangle BCIA, which equals to half times 2 BC times RA. Right. So now let's just consider AE plus AF. AE plus AF equals 2, because AE plus AF, that is AB plus EB, plus AF. AF is AC plus CF. And we know that BE equals to BD, CF equals to CD, which means AE plus AF equals to A plus B plus C, right? That is AB plus AC plus BC, because BE plus CF equals to BC. And for this one, times 2, that is times 2A, right? BC is A times RA. So we know that the triangle area, the ABC area as triangle ABC, it equals to this one equals to the area of AEIAF minus area of BEIAFC, right? Which equals to half of A plus B plus C minus 2A times RA, right? And this, so from here we know that RA equals to twice of the triangle area divided by minus A plus B plus C, right? It is true for the RB and RC. You can use the similar format to do the calculation. That's the same. Now let's think about the relation of the RA, the radius of the X circle, and the radius of the circumcircle, right? RA and R. So recall that we want to do the proof that RA equals to 4R times sine angle, half of angle A cosine, half of angle B cosine, half of angle C, right? And let's look at here. RA is the distance of EIA, right? So let's consider about RA divided by sine angle A divided by 2. What is that? Right, RA divided by sine half of angle A. This is angle A. This is RA. So RA divided by sine half of angle A, that equals to AIA. Right? And AIA divided by cosine half of angle B. AIA is this one, and this is angle B. This is half of angle B. This is half of angle B. So AIA divided by cosine half of angle B, it equals to IAIB. Right? And IAIB divided by cosine. So now let's just think about IAIB. Okay, how to calculate about the IAIB? We already know that the circumcircle of the radius of the circumcircle of the triangle IAIBIC equals to 2r, right? And we know this angle equals to this one. This angle equals to 90 degrees minus half of angle C, right? That means IAIB can be calculated by the radius of the circumcircle of the triangle IAIBIC, right? So it equals to, I just write here, IAIB equals to 2 times the radius times sine angle IAICIB, which equals to 4r times sine 90 degree minus half of angle C, right? So it equals to 4r times cosine angle C divided by 2, right? Half of angle C. Okay, now we can relate all of these things together. So we know that RA equals to 4r times cosine angle C divided by 2, which is IAIB times cosine half of angle B, which is AIA times sine angle half of angle A, which is RA, right? And we just prove it. Look at it here. Right, we just prove it. And we have another half that we want to prove that this radius, the RA, equals to the radius of the incenter times cotangent half of angle B, cotangent half of angle C. So for this one, we need to know the relation of this radius and the radius of the incenter, right? We already know that incenter is here. So if we find the projection point from the incenter to this line, let's call this point as G, right? So if we do the projection from I to BC, then we know that IG is radius of the incenter R, right? So before we do that, let's just think about how to calculate the EB, the length of the EB, right? How can we find out the length of EB? The first thing we know that is the triangle AEIA. The triangle AEIA is congruent to the triangle AFIA, right? So I guess it's better that I have another paper here, so I can keep the figure, I can keep the target equation. So this is our target equation, this is a figure, right? I'm saying that we want to calculate, we want to find out. Let me do this way, it's easier. Okay, we want to find out the length of BE, right? All the length of the BD, right? So we already know that AB plus BE. AB plus BE. Because the triangle AEIA is congruent to triangle AFIA, right? That means AE equals to AF. So AB plus EB, that is AE, equals to AF, which is AC plus AF. And we know that BE equals to BD, CF equals to CD. So BE plus CF equals to BC, right? We have these two equations, and it can be rewritten as AB is C plus BE equals to AC, which is B plus CF. And we have BE plus CF equals to A. So we know that from this one, that means BE minus CF equals to B minus C, right? Which means BE equals to A plus B minus C divided by 2, and CF equals to A minus B plus C divided by 2, right? Yeah, this is correct. So based on this, we calculate for the BE and CF. BE equals to BD. Notice that BE equals to BD. Okay. So the next thing is that I want to calculate for the CG. Okay, I want to calculate for CG. So let's just do it separately. I will keep the naming to be the same. Let's just think about the Excenter. Okay, this is the Excenter I. So we know that we find the projection here. We call this point as G, right? Let's consider that we have this point, this as G, this as J, and also we have this as K, right? So basically we know that AK equals to AJ, and CJ equals to CG, and BK equals to BG, right? So we can calculate for the CG, right? Because AK plus BK equals to C, and AJ is AK, right? So AK plus CJ is CG, so CG equals to B, and CG plus BK equals to A, right? Which means, let's just consider about the CG here. So we want to find out the CG. We want to replace the AK here, so AK can be written as C minus BK, right? So C minus BK plus CG equals to B, and also CG plus BK equals to A, which means CG equals to, we just sum them together, right? And put this C on the right side of the equation, so it equals to A plus B minus C divided by 2. So we find that CG is CG equals to BE, right? here, BE equals to BD. So CG actually equals to BD. Okay. Now we think about R times cotangent half of angle B, cotangent half of angle C, right? So the first thing is that R times cotangent angle half of angle C, R times cotangent half of angle C. That equals to CG, right? Because the CG divided by IG, R is IG, right? CG divided by IG equals to cotangent half of angle C. So, and it equals to, we already know CG equals to BD, right? BD. Okay, now we want to calculate for the angle BIAD. We know that angle BIAD plus angle CBIA equals to 90 degrees, right? And angle IBC equals to half of angle B, and angle IBC plus angle CBIA equals to 90 degrees, right? Which means angle BIAD equals to angle IBC equals to half of angle B, right? This angle plus this one equals to 90 degrees. This one, the angle BIAD plus this angle equals to 90 degrees. So this one is actually, the angle BIAD is actually half of angle B. So BD divided by, BD times cotangent half of angle B, that equals to DIA, which equals to RA, right? Which means RA equals to R times cotangent half of angle B times cotangent half of angle C. Okay, so we just prove this one. And for other two equation chains, they are the same for this one, just rotate the letters, right? Okay, great. Let's check on the property 5. Okay, property 5. The triangle area equals to P minus A times RA equals to P minus B times RB times equals to P minus C times RC, right? So P is a semi-parameter, right? So P equals to half of A plus B plus C, right? So we actually already finished the proof of this one, right? Look at it here. Because RA equals to 2 times of the triangle area divided by minus A plus B plus C, right? So if you think this one carefully divided 2, so equals to triangle divided by minus A plus B plus C divided by 2, which equals to P minus A, right? P is half of A plus B plus C minus A. That is exactly this one, which means the area of the triangle equals to P minus A times RA. Right, we just proved that in property 4, right? So this is true, and this one is actually just some calculation here that we want to prove the area of the triangle can be rewritten as this form, right? So let's just do the calculation. It's we want to find out this one. So RA times RB times RC. We just use this one, right? That's actually 8 times of the okay, that's RA, RB, RC divided by minus A plus B plus C, A minus B plus C, A plus B minus C, right? That's RA times RB times RC, and divided by squat of, so RA, RB, that is 4 S squared times minus A plus B plus C times A minus B plus C plus this one divided by A minus B plus C, A plus B minus C, right? Plus divided by A plus B minus C minus A plus B plus C. Right, we want to simplify this one. So remember the Helen equations that we can just put A plus B plus C for here, and put A plus B plus C for here, right? And we know that the bottom side, if we do squat, let me just do it step by step. So it equals to 8 A plus B plus C, right? That's very straightforward for here. For this one, this is actually 2p, actually 2p minus A, right? That is this one. And for this one is 2p minus B. For this one is 2p minus C. And for this one is 2p. And we know that p minus A times p minus B times p minus C times p, that's S squared, right? So it equals to 16 of the S squared, right? And then divided by this one. So let's just move the 4s squared out, which is 2s, right? And squat. Let's just times for each one, we want to put them similar to this one, which means that we can have the denominator as 16s squared, right? But for the first one, we have A plus B plus C. All of them has A plus B plus C. For the first one, we have A plus B minus C, and for the second one, we have minus A plus B plus C, and for the third one, we have A minus B plus C, right? So it equals to, let's see. So this one is 2s A plus B plus C, right, for the denominator. And for the denominator, it's like we have 4s out, which means we have 1 by 2 and squat A plus B plus C times, look at this stuff, A minus A, so they cancel each other, B minus B, they cancel each other, minus C and C cancel each other. We will left B plus A plus C, right? So this is half, this is half, they cancel each other. This is A plus B plus C squared and squat, that's A plus B plus C, so this equals to the triangle area, right? Okay, and we just proved this one. For the third one, the first half is pretty straightforward, right? Because we want to prove that square 3 times RA, RB, RC divided by RA plus RB plus RC is less or equal to RA plus RA times RB times RC divided by squared RA RB plus RB RC plus RC RA. Basically, we want to prove this one. So we want to prove that 3 times RA RB plus RB RC plus RC RA is less or equals to RA plus RB plus RC squared, right? And that's obviously true because RA, if we extend this one, that's RA squared plus RB squared plus RC squared plus 2RA/RB plus 2RA/RC plus 2RB/RC, right? And if we put this on the right side, on the other side, so that's minus 3 RA/RB plus RB/RC plus RC/RA, right? We want to prove all of this larger or equals to 0. And this one can be rewritten as half of RA minus RB squared plus half of RB minus RC squared plus half of RC minus RA squared, right? This obviously is larger or equals to 0. And equals to 0 only if RA equals to RB equals to RC, which makes the triangle ABC to be a equilateral triangle. Okay, so the first half of the inequality is easy to prove. For the second one, in the Chinese version of the video, I actually made a mistake and then I fixed that. So let me just do the correct way here. It's all about how you choose the concept of the inequality chain, right? How you choose the inequality chain. The first thing that I want to remind the audience, if you may not familiar with mean equality chain, we have that the harmonic, harmonic mean, right? Harmonic mean, which is so for a series of the number, let's say we have x1, x2 to xn, okay? For this series of number, we have a harmonic mean, which is I believe is n divided by I equals to 1 to n x1 over xi. Right, I believe that's a harmonic mean. Yeah, I think I'm right. This is a harmonic mean, and for the geometry mean, so for this, for the series of the numbers, right? The geometry mean is n squared of the production of all of these number. Okay, that's a geometry mean. And we also have arithmetic mean, which is simply just add them together divided by n, right? Also we have quadratic mean, right? Which is we do the summation of the square of each number and then divided by n. Note that this divided by n is inside of the square root. Okay, and for these means for these mean numbers we have that hm is less equal to gm and less equal to am and less equals to qm, right? And equal sign happens only if xi equal x1 equals to x2 equals to xn. Okay, they're all the same number. That's a basic concept I want to talk about here. And for the proof, let's see, we want to prove that the triangle area is less equals to square 3 divided by 3 RC 2 by 3, right? And we already know that the area of the triangle can be written as RC divided by square root of RARB plus RBRC plus RARC, right? So basically we want to do the comparison of this one. We want to prove that this is less or equals to square 3 and RARBRC 2 by 3, right? That means we just need to prove, right? This inequality is equivalent to prove this one. RARB plus RBRC plus RARC is less equals to RARBRC 1/3 minus, actually, right, divided by RARBRC on both sides. So if you look at this one, it's actually can be thinking of the geometry mean, right? So this one is actually 1 divided by square root RARBRC, actually this one, right? Which can be written as RARBRC, right? So if we use the inequality chain that hm is less equal to gm, right? So we know that this one, the square root 1 to RA 1 to RB 1 to, so actually this one is larger or equals to 3 divided by this one, right? So that is RA 1 over RA plus 1 over RB plus 1 over RC, right? But actually we want to calculate for this one, so square 3 times 3. So let's do this carefully. Square 3 to 3 times this one, RARBRC minus 1 divided by 3. That is larger or equals to square 3 by 3 times 3 of 3 divided by 1 over RA plus 1 over RB plus 1 over RC. Right. And here, this one equals to square 3 times RARBRC divided by RA or RBRC plus RARC plus RARB. right? And now we want to prove this one is larger or equals to RA, RB, RC divided by squat RA, RB plus RB, RC plus RA, RC. Let me just check if I do anything wrong here. Oh wait, no, here is wrong, right? This is wrong. This one means each xi is 1 over Ra, right? Which means for the harmonic mean is the reverse of this one, which means we should rewritten this. Sorry, let me just rewritten this. This is wrong. So we want to calculate for this one, right? Square 3 by 3, Ra, Rb, Rc, this one. We want to calculate for this one. So this we can rewritten it as square 3 1 over Ra times 1 over Rb times 1 over Rc, right? For the harmonic mean, so here each xi is represent for the 1 over Ra or 1 over Rb or 1 over Rc. So for harmonic mean we need to reverse it again. So it's larger or equals to square 3 by 3. We need keep the coefficient here times this one. So that is 3, right? The number is 3 divided by Ra plus Rb plus Rc. Right, and it equals to square 3 divided by Ra plus Rb plus Rc. Times Ra, Rb, Rc.